Lesson 100, estimating square roots and irrational numbers. So we are going to look at perfect squares, and that is just where you have a number and you square it. The answer is called a perfect square. So we're going to look at perfect squares. So we take 2 squared, and that's going to be 4. 3 squared is 9. 4 squared is 16. 25. We're going to go all the way up to 12 squared. So all of these numbers, 1, 4, 9, 16, 25, 36, all those numbers are called perfect squares. Well, all the numbers in between, like 2 and 3 and 5, 6, 7, 8 and 10, 11, 12, 13, 14, 15, all those numbers are not perfect squares. But they fall between these numbers. So like 32 is between 25 and 36. Okay? So if I took, say, the square root of 3, it just equal, I didn't mean 3, I meant 9. Sorry, let's change that to a 9. Square root of 9 just equals 3. The square root of 36, that just equals 6. Now if you have the square root of a number that is not a perfect square, like the square root of 33, you can look and find what 2 numbers it is between. So if you look at 33, it's between 25 and 36. So the square root of it will be between 5 and 6. No, not exactly. So these numbers are not going to be a decimal number that we can write, okay? But it will be between 5 and 6. Because the square root of 25 is 5, the square root of 36 is 6. So the square root of 33 will be between 5 and 6. So right now, all I want you to look for is what 2 numbers will they be between. So the square root of 94, we want to know what 2 numbers is that between. They call them consecutive numbers, because we want 2 numbers that are right next to each other. So what 2 consecutive numbers is the square root of 94 between? What did you get?
9 and 10.
9 and 10. Excellent. And the square root of 5 is between, so we look and see where 5 is between 4 and 9, so it's between 2 and 3. And the square root of 127. So we come down here, we look, 127 is bigger than the square root of 121, smaller than 144. So it's going to be between 11 and 12. And I'm going to do one more example. Square root of 72. So we just find where 72 would fall, and it's between those 2 numbers, 8 and 9. So at this point, if they give you square root, you kind of know where it's going to fall between what 2 numbers. Now if it's closer to one than the other, so for instance, the square root of 5 is going to be closer to the number 2 than it is to the number 3. So if you had to put it on a number line, you'd kind of put a dot in between 2 and 3, but a little bit closer to 2. Okay? Now these are called, if they're not perfect squares, if they're between perfect squares, they're called irrational numbers. And an irrational number They are numbers with decimal points, or decimal, not points, parts. Decimal parts that continue without repeating or ending. So that continue without end and without repeating. So you know the W with the slash means with, the W slash O means without. We really would put it closer together there. There we go. Now, when we do something like what we did yesterday, Pythagorean Theorem for right triangle. If you remember the Pythagorean, we better practice saying that, Pythagorean Theorem. Everybody say Pythagorean Theorem.
Pythagorean Theorem.
Nice. Good job. It's a squared plus b squared equals c squared. So you take the leg lengths. We're going to call this one a and that one b. They're both 5, so it doesn't really matter which is which. And you have 5 squared plus 5 squared is going to equal c squared. So when you add 25 and 25, you get 50. And 50 is not a perfect square. We can't look up here and find the square root of 50 and know what it is, but we do know what it's between. So c equals the square root of 50. That's the exact answer, but it will be between 7 and 8. And we can't write it as a decimal number that ends because it continues forever. But we could estimate it. We could maybe round it to the tenths or the hundredths or something. But we just know that it's going to fall between 7 and 8. And that's the end of the lesson.